Hey class, we're looking at weather and climate, and our essential question that we want to be able to answer after our chat here is how does weather and climate impact different environments? So our big ideas, our learning targets, understanding the difference between weather and climate, understand the impact wind and water have on regional weather and climate, and then understanding how mountains influence temperature and precipitation. How are we going to be able to apply what we're learning? Apply understanding of weather and climate to understanding maps, so mapping comprehension, and then understanding the role of physical landforms that they have on weather and climate and how, again, that impacts various regions. So what is it like outside right now where we live? Is it hot, sunny, wet, cold? Is this what it is usually like outside for this time of year? And if we look out the window right now, yeah, it's kind of wet and rainy. Summer's really changing over to fall. So then we have to decide which of the above questions are about weather and which of the above questions are about climate. So weather, by definition, is short-term changes in the air for a given place and time. And then climate would be a region's average weather conditions over a long period of time. So you're taking a bunch of data over a long period, compiling it, and figuring out what the average is. So when we look at that first question, what is it like outside right now? That would have to do with weather. And then the question, is this what it's usually like outside for this time of year? That would have to do with climate. So just a couple pictures to kind of give you a visualization. Here we see the storm front moving in, or the clouds. That would be a change in weather, right? Short term, it'll probably pass over the next few hours, or maybe the storm will last a day, but that'll change. Here again, a change in the weather. We see clouds moving in, some kind of front with that. So it's a short-term change to the conditions outside. So the top picture here, we're looking at an image of the Holgate Glacier in Alaska taken in 1906. The glacier is clear. This would be the glacier here and here. The thick ring around the central outcropping in the bottom image, that's taken from 2003. And then we see the recession of the ice. Only a little bit of it remains. So for us then, that is a change in climate. Long-term change over a given period of time. Looking at these three images, this one's 1995, 2003, and then 2013. Of course, there's going to be seasonal change in the levels of the water, but this is a lake in Iraq, and over the last decade, it's seen changes to its year-round low water level, so there isn't as much rain falling. This would be then a change in climate. They're not getting rain like they normally should, so it moves into drought stages, and the water levels aren't recovering, and basically the lake is shrinking. This is 2000, and this is 2014. This is the Aral Sea in Kazakhstan and Uzbekistan. It was once the fourth largest lake in the world. It's already lost a lot of water because of different damming projects on the lake. And then it basically split into an eastern and western lobe, they would call it. But then during dry season, it's the eastern is totally disappearing. It's just gone. That would be a change then in climate, in addition to human environment interaction with the damming on the lakes. So the sun's role then, the impact of the sun in weather and climate, the solar rays are direct and concentrated. The Earth being a sphere, it gets more direct sunlight around the middle. Here, the equator, the middle, and less near the ends, the polar caps, right? Because remember that we have the axis, and then the Earth is tilted, and it's rotating on the axis. The low latitudes, are mostly hot year round, so 0 to 30. The middle latitudes, 30 to 60, are going to see the most change in seasons, right? And look where we are here, right? Middle, excuse me, middle here. And then the high latitudes are colder temperatures year round, and that's going to be from 60 to 90, and we can't see it on the bottom there. But we have low, middle, and high latitudes. Low, middle, high. Global winds. These are made with the prevailing winds, and those are winds that blow in the same direction over large areas of the earth. As the air cools, it gets heavier and sinks, and then as the air warms, it gets lighter and rises. So the cold air is going to come in and push down underneath the warm air. As the warm air rises, the cooler air moves in, taking its place. This is what creates wind. Warm air rises at the equator and flows towards the poles, and the cold air sinks and then moves back towards the equator. The planet's rotation then causes the prevailing winds to curve east or west rather than flowing directly north and south. Ocean currents. Like wind, streams of surface seawater move heat around the earth. Wind drives these currents, and the water temperature affects the air temperature near it. So the temperature of the water is going to affect the air temperature that's near it. So for example, the Gulf Stream is a warm current that flows along the U.S. coast. Along the East Coast, we have our Gulf Stream. It then flows east across the Atlantic, and it becomes known as the North Atlantic Drift. As the warm current flows along northwestern Europe, it heats the air, and then those westerlies, the winds that's blowing in the western direction, blows the warm air across Europe and creates a nice climate environment there. And then impacts of large bodies of water. They also impact climate. When water heats and cools more slowly than land does. So land, you can kind of think of it like the land hangs on to its temperature. So larger bodies of water make the temperature of the land nearby milder. Some examples: coastal California does not have large temperature ranges as we would have inland. Michigan is surrounded by the Great Lakes and has higher temps than other places as far north. Large landforms then also impact a region's temperature and precipitation. Keep in mind, this is really important, temperature decreases with elevation. Okay, so as we move up a mountain, elevation, temperature decreases. Okay, so the higher you get in your elevation, the colder it's going to be. The landform can also create wet and dry areas. This is known as the rain shadow effect. A diagram will pop up on the next page to show this, but air blowing against a mountain is forced up. As it rises, the air cools, and then as it gets heavier, it's got to drop its precipitation, which falls as rain or snow. The side of the mountain facing the wind has good vegetation growth, and the other side is much drier due to precipitation already have fallen. There's no more rain left in the clouds once it makes it over the mountain. So here, the warm, moist air is forced to rise over the high areas, right? This will be letter A in your notes. Air cools and condenses, and this forms clouds. Letter B. It rains or any other kind of precipitation. This would also be letter B. And then the air descends, warms, and becomes drier. Okay, so it drops all the rain here, and then as it can finally get over the hill or the mountain, it doesn't have any precipitation left. So there's no precipitation left to fall in this area. So we get the shadow, the rain shadow. Here's some examples. So looking at the state of Washington, we see the high elevation, the Cascade Mountains. As the wind is pushing the air in. It's trying to rise up over the hills. We get all the precipitation on this side. And then as it finally makes its way over, there's nothing left here. And then we see this kind of landscape develop that's not as green as this, right? Because there's no more precipitation left to fall there to help the plants grow. And then further south in South America, here we have the Andes Mountains chain. And we have two prevailing winds hitting both sides of the mountain. But we get the Atacama Desert here as a result of the rain shadow. We get lots of rainfall here, right? Well, R for rain. And then as it works its way over, there isn't any precipitation left. And then further south, the Andes Mountains, the elevation isn't as high. So we do get a rain shadow on this side as well, but it isn't as extreme as it is up here. So difference between weather and climate, understanding that, and then the impact of water and land masses that it has on the climate of a region. Those are what we need to go away with as we end this. We'll talk to you later.